Hello, in this video we're going to explore something that for me it's very interesting in physics, that is analyzing motion diagrams. Motion diagrams is kind of the first thing you have to learn in physics when you do graphs. So I strongly feel that if you understand how to interpret motion graphs, then the other graphs that uses another magnitude will be easier for you. So today, in this video, we're going to explore how to get the motion diagrams, how to interpret motion diagrams, and what type of motions we can interpret using these motion diagrams. Okay? So to start, I would like that you imagine the following situation. Imagine that you're here, like you're here, and let's say that we have a stopwatch. So we have a stopwatch here, and the stopwatch is showing you that we start at 0 seconds, okay? And after 1 second, we're here on this position. And then in another second, we're here. So it's like we're moving, right? And then here and here. Okay, every second we're moving, but notice that we're moving the same distance. Okay, let's say that we're moving 4 meters. So every second we're moving 4 meters. Okay, so imagine you're moving and every second you're moving 4 meters. Now, how does it look, a graph of displacement versus time in this exercise? Okay, how should it look? So let's say that this is time and this is displacement. Okay, remember that for some books S stands for displacement. And notice that every second, so 1, 2, 3, and 4, okay, every second we're moving 4 meters. So 4, 8, 12, 16. 4, 8, 12, 16. So essentially what it's happening is that every second we're moving 4 meters. Okay, so what do you think is the type of the motion described here? How is the graph? The graph is going to be a linear function, or the graph is a linear trend. Okay, so what we're seeing here is that we're moving at constant speed or steady speed, and as you could see, every 4 meters, every second we're moving 4 meters. So it means that this is a graph related with steady speed or steady velocity. Okay, so the graph for steady speed of displacement versus time is a linear trend. Okay, if you have a linear trend for displacement versus time, then the motion is at steady speed. So how do you think is going to be the graph, this graph, but if I want to use velocity and time? So instead of doing the graph of displacement versus time, I'm going to do the graph of velocity versus time. How do you think is going to be the graph? So look at that, the gradient of this line is always the same because it's a linear function. So it's going to be 4 meters in 1 second, so it's 4 meters per second. So that will mean that our graph will be a straight line at 4 meters per second, but it will be a horizontal line. So when we have a steady speed, the graph of velocity versus time is going to be a horizontal line. Okay? So this is the first part. When you have a steady speed, that it's like the highly used in problems, but it's not the only one. We're going to see the other form. Now let's imagine that this is what is happening to you when you're moving. So you're here. Let me put like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and okay, 10. 10 is here. Okay, so now imagine that you're here, but after 1 second you move here. Okay, so this is 0, 1 second, but in the next second you're here. And in the next second you are 1, 2, 3, you're here. Okay, notice that we're increasing the distance through time. So now it's not a steady speed, because if it's a steady speed, same distance in the same time. But in this case, we don't have the same distance in the same time. Let's see how the graph looks like. The graph should look like so this is going to be displacement, and this is going to be time. Let's say that the time is in seconds, displacement in meters. Let's say that this is meters. Okay, so for 1 second we're at 1 meter. Okay, this position. At 2 seconds we are okay, we can do it like better, like 1, 2, and 3. Okay, so at 1 second we're here. At 2 seconds we're at 3. Okay, 3. And in the 3rd second we are 4, 5, 6, 7. Okay, so notice that now that the graph is not longer a straight line. Okay, should be a curve. In this case, if it's a smooth curve, in math we're gonna say that it's a quadratic function or a parabola. Okay, so it means that the motion is accelerated. So to sum up, we have accelerated motion if the graph of displacement versus time is going to be a non-linear trend. Okay, non-linear trend. Maybe you can see the video about trends to understand about what are the types of trends, and you understand how the graphs are related with trends, and with that we can get explanation of the motion. So if the graph of displacement versus time is a non-linear trend, we will have an accelerated motion. Okay, so what happened to the graph of velocity versus time for this motion? Velocity versus time for this motion. So velocity in meters per second and time in seconds. Okay, what is gonna happen here is that the speed is changing. So in the best case is going to be a linear trend. Okay, and if it's a linear trend, then the motion is at constant acceleration. Okay, so accelerated motion when the graph of velocity versus time is a linear trend. Okay, so if you have a linear trend, in the graph of velocity versus time, we're going to have an accelerated motion. Okay, it's a constant acceleration. The acceleration is not changing, it's the same. What is the acceleration? The gradient, or the gradient or the slope of this line. Okay, that's going to be the accelerated motion. So to sum up, what are the types of motions we have seen here? We have seen constant speed, okay, or steady speed, or constant velocity, in which the trend of displacement versus time is a linear function, and if we graph velocity versus time, it should be a horizontal line. Okay, and we have seen accelerated motion, in which the graph of displacement versus time is going to be a nonlinear trend, and the graph of velocity versus time is going to be a linear trend. Okay, so this is how you can interpret graphs. Graphs may change, obviously. Sometimes you have accelerated motions of some part and it's going to be constant speed, or at rest, that is no motion, no change of position, I mean zero displacement. And this is a way that you can interpret graphs of motion. Okay, so remember the types of motion. Just as a comment, tell me, what do you think is the most difficult trend you saw here? Okay, what is the most difficult graph you saw here? Maybe we can do an exercise with this graph for you to understand. Okay, so see you the next time. Remember that you can find me in any of my social networks with the same name, and remember that anything you need, just comment, like on the video, and subscribe to my YouTube. Goodbye, have a nice day, and I hope that you are doing excellent. Goodbye.